Quantum perception of color is a theoretical framework that uses principles of quantum mechanics to describe how humans perceive color. It treats color perception as a quantum-like system, defining perceptual state and observables to model attributes like hue, saturation, and brightness more rigorously than classical models. This approach helped explain phenomena such as chromatic opposition and color consistency using concepts like quantum state and measurement uncertainty. Here is core concepts. Quantum-like framework. The theory treats color perception as a mathematical model similar to quantum mechanics. This allows for the application of quantum concepts to subjective experience. Perceptual status. This represents the preparation of a visual scene and are the equivalent of quantum state in this model. Perceptual observables. These are the measurable property of color like hue and saturation and are analogous to observables in quantum mechanics. Uncertainty relations. The theory had successfully derived uncertainty relation for chromatic opposition, which is the degree of opposition between colors, example red versus green. This provides a theoretical confirmation of the quantum nature of color perception. Quantum information. The theory uses concepts from quantum information such as effect, generalized status, and post-measurement transformation to provide a more precise definition of color perception attributes like brightness and chroma. Geometric models. This framework has helped reveal the importance of hyperbolic geometry in colorimetry and can confine the color cones to a finite volume color solid, unlike classical model. And application as result. Chromatic opposition. The quantum model provides a deeper understanding of chromatic opposition and its role in encoding visual signals. Color consistency. The theory has been used to rigorously drive phenomena like the lightness consistency phenomenon, which is the ability to perceive the color of an object as a constant despite the change in illumination. Post-measurement transformation. The model connects post-measurement state changes in color to concepts like Lorentz booster and relativistic addition law. Analogy to qubit. This theory utilized a concept called a rabbit, which is the real analogy of a qubit. In this model, the two states a rabbit can be measured in have a concrete, important meaning in color perception. So, what is a quantum-like model? Quantum-like model for unconscious conscious interaction and emotional coloring of perception and other conscious experience. Quantum measurement theory is applied to quantum-like modeling of coherence generation of perception and emotion, and generally for emotional coloring of conscious experience. In quantum theory, a system should be separate from an observer. The brain performs self-measurement. To model them, we split the brain into two subsystems, unconscious and conscious. They correspond to a system and an observer. The state of perception and emotion are described through the tensor product decomposition of the unconscious state space. Similarly, there are two classes of observables. For conscious experiencing of perception and emotion, respectively. Emotion coloring is coupled to quantum contextuality. Emotional observables determine context. Such contextualization reduces degeneration of unconscious status. The quantum-like approach should be distinguished from consideration of the genuine quantum physical process in the brain. In our research, the brain is a macroscopic system which information processing can be described by the formalism of quantum theory.